Hey guys, I'm here today to do a pretty quick discussion on a phenomenon called El Nino and a sort of an opposite effect called La Nina. So these are two things that you probably have heard of before. A lot of different weather events around the country and around the world are linked to these two things. The severity of hurricane seasons here in Florida, California coming out of drought seasons for a couple of years. There's a lot of big important situations weather-wise that are linked to these two types of years. We have what's called El Nino years and La Nina years. So to start, talking about this, we need to think back to some of the things that we learned about ocean currents a couple of months ago. And so this map that we're looking at here is the Pacific Ocean. Okay, and so if you remember when we were talking about the ocean gyres, we looked at along the equator, the equatorial currents that are pushed both above and below the equator. They're being pushed along by the trade winds, okay, pushing westward across the Pacific Ocean. These equatorial currents are going to be pushing a lot of cooler water from the eastern Pacific over towards the middle of the Pacific Ocean. Okay, this cold water is coming from these strong upwellings that happen right here. Okay, if you remember when we talked about upwellings, this is caused by trade winds blowing perpendicular off the continent, and so as it pushes the water off of the coastline, deeper water comes up and replaces it. Okay, so we talked about how that water is cold, it's full of nutrients, it stimulates a really good ecosystem and food web where there's really good fishing grounds. And so those really strong upwelling situations that are happening here off this coastline are producing all of this cold water. And if you also remember, there's the Peru current, or the Humboldt current, it's also called, that comes up this western coast of South America. And so between those two things happening, you've got a patch of cold water here off the coastline. And so these strong trade winds and these equatorial currents will push those cooler waters across the Pacific Ocean. And so you'll actually have a pretty cool area of water right here along the equator compared to what you typically would have in an equatorial region. So pretty cool water at an equator. And so that's because of those cooler waters being pushed by those trade winds. This has a big effect on weather. When you have cooler waters, you've got drier atmospheres because there's less evaporation happening. And so some of the ways that the wind currents move and things like that, these cooler ocean waters will actually play a role even up here in California and having a drier atmosphere. That's why California a lot of times is in kind of more of a drought condition. They're very dry, they don't get a lot of rain. And so these temperatures playing out across the ocean play a big role in the weather. Okay, you'll typically have a lot of strong like monsoon and hurricane situations happening out here because you've got this really warm water here, and so you've got a lot of evaporation, and so storms are going to build and strengthen over this part of the ocean, whereas over here it's not going to happen so much because there's cooler water, less evaporation happening. All right, so this is what it typically looks like in the Pacific Ocean. This would be what we would call a normal condition. Okay. Let's see, this information I just put up here is basically the same thing. Let me move this for a second in case you need to pause it to copy notes. Okay, so this is just showing again the upwelling that I was just talking about. So that's where this cold water originates, from the upwelling and also from the Humboldt current that's being delivered up this way. So if you remember these ocean currents, the gyres are going to go this way here in the southern hemisphere and here. Okay. All right, so big patch of cold water gets pushed westward. All right, and so you've got a real cool region here compared to the rest of the equatorial regions around the world. All right, so I'm going to play this video illustration here. So this is just kind of a reminder here of what the upwelling is all about, okay? Strong trade winds. Let me pause this for a second. So you've got these strong trade winds coming off the coastline, and so pushing a lot of water westward, all right? And this water is upwelling here in the same location, and so that water that's getting pushed westward is very cool. It's very cold, okay? Now, what happens during El Nino conditions, like it says up here that we're talking about now, and you'll see this move in a minute, but during an El Nino condition, the trade winds weaken, okay? So they're not as strong as they are during a normal year. And we actually don't know why this happens. scientists have not fully explained. We don't know what causes the El Nino conditions. It has nothing to do with climate change. It's not human related or anything like that. It just happens. The trade winds, they slow down some years. Every few years, they're just not as strong. When that happens, the upwelling's not as strong. Okay? Not only is the upwelling not as strong and not as much cooler water is being delivered, but now these warmer waters over here start to kind of seep eastward and make their way across the Pacific Ocean. So that warmth wants to kind of spread out. And when you don't have these strong winds and strong currents pushing it and kind of keeping it over on that end of the Pacific, that warmth, let's see here, that warmth starts to seep in this way, all right? And so, and it's not so much that the warmth is seeping in, but it's more so that there's no cold being pushed westward anymore. Okay, so we are not going to draw this because I don't have any maps to print out and give to you in any way. But if we were in class right now, we'd kind of draw this. This is just an illustration of what we just looked at. Okay, so now during El Nino conditions. So you can see this is the same map I showed you before. The only difference here is that this red, instead of ending right around here, it's now pushed all of this further away east. And it's this is just what we saw in the illustration, that animation just now. The upwelling is weaker, okay, so there's not as much cold water. And in addition to the upwelling being weaker and there just being less cold water, these trade winds are weaker, which is why the upwelling is weaker. And so these weaker winds are not pushing this way, okay, so there's not as much of a westward push across the ocean anymore and not as much cold to be pushed. And so basically this warmth just kind of moves back this way and distributes itself back eastward across the Pacific Ocean. And so first of all, this weaker upwelling causes a lot of ecosystem changes in that region. Locally along some of those coastlines, you'll see big die-offs of fish populations, big die-offs of seabird populations because the fish are no longer there to feed on. And it creates this whole change in the ecosystem and kind of a bottom-up effect throughout the food web, if you remember us talking about that. And the fisheries, those big fishery, commercial fishing businesses that are so strong here during a normal upwelling, they're not catching as much fish, and so it's economically devastating to these countries here when there's an El Nino year. Okay, in addition to that, now you've got warmer atmosphere here, warmer water here, so you have more evaporation, and so the drought that typically is consuming Mexico and California during most years, they actually get a lot more rain during an El Nino year compared to normal. All right, and the conditions during an El Nino year, they actually expand all the way around the world. And so yes, we're just talking about what's happening in the Pacific Ocean, but the Pacific Ocean is huge. When you look at a globe, an actually rounded shape of the Earth, you'll see the Pacific engulfs, a third of our actual globe. And so the effects of a warmer Pacific Ocean are very far-reaching, all the way to the other end of the world. And so for your assignment this week, one of your assignments is you're actually going to find 5 different ways that El Nino years, different effects they have, 5 different effects around the world. I would suggest starting with the change in the fishing, okay, the fisheries off the coast of Ecuador and Peru. Those lower upwelling years are going to not produce the phytoplankton blooms that support those really strong food webs. So you could start there with the changes in the fishing population and the fishing economies. You could also look at the kind of the lessening of the drought conditions in California and Mexico. Those are 2 really easy ones. You could look at the hurricane seasons, okay, whether or not we're in an El Nino year or not, plays directly into Atlantic Ocean hurricane seasons. And so you're supposed to find 5 things. So that's 3 right there you could do, okay? So the fishing industry off Peru, local weather changes in kind of the California, northern Mexico region, and Atlantic hurricane strength of the hurricane seasons that we see. All right, almost done here. And so here's just a good comparison, okay? So strong trade winds create a strong upwelling and all that cold water being pushed very strongly halfway across the Pacific. Okay, and so you've got a lot of evaporation here and storms building, and you don't on this side. Whereas when you've got the warmer Pacific Ocean all the way across, you're going to have a lot more precipitation happening all across the Pacific Ocean. And so this is going to play a huge role in the, in the local weather in these areas. Okay, so just some quick facts here on El Nino. Usually it's about a year that the conditions last. Sometimes there are El Nino years that last 2 years or 3 years, but usually it's about a year. And these occur, it's not really a very stable cycle. Sometimes every 2 years, sometimes every 7 years. So it can be anywhere within that range. La Nina is going to be the opposite of El Nino. So instead of having trade winds that weaken, La Nina years are actually years when the trade winds are stronger. Okay, so those winds pushing across the Pacific Ocean, they're stronger than normal. And so they're pushing more water, and those upwellings are even stronger, so more cold water is being brought to the surface. All right. And so that kind of blue region is going to extend further over into that other portion of the Pacific. Okay, and these would be the worst drought years for California because the ocean's going to be even cooler off the coastline. Okay, so that's it for El Nino. Hopefully that was easy to follow. Again, these are things that you'll hear about on the news all the time. Weather Channel, they affect our hurricane seasons. They affect our weather. How rainy of a rainy season we have, how dry of a dry season we have, things like that. And so important to know because you'll hear about them for the rest of your life on as far as our climate goes. So there is a second PowerPoint for this week. It's called Ocean Resources. I'm actually not going to go through and do a discussion on that one. I can open it up here. It looks something like this. And it's pretty straightforward. It just has to do with some of the different types of resources we get from the ocean. It doesn't cover everything, but focuses a lot on fisheries. And so as you go through it, you'll see talking about ocean resources, just some different terminology like commercial fishing and some of the different sustainable methods of commercial fishing. It goes through some of the different types of nets that we use. And so as you get to these different types of fishing methods, like the long line fishing, there'll be a YouTube video down here. As you go through all of them, there are different YouTube videos. So I'd suggest you watch these. They're really short, just like a minute long, and they give you, it's a really good animation of how all the nets work. So go ahead and watch all of those. But as you go through this, eventually you'll get to an aquaculture section. And your second assignment has to do with aquaculture. There's a PDF that you're going to kind of scan through and a document that goes along with it, and you'll kind of pull out some information and look at kind of the pros and cons about aquaculture versus commercial fishing, and what are some of the more sustainable ways for us to get food from the ocean. So those are your two assignments. You have one on El Nino and one on aquaculture, and so those are already posted for you on Canvas. You'll do the two assignments. This Ed puzzle is another assignment, and then I'll post a quiz as well. It is Sunday night, and I haven't quite finished the quiz yet, so I'm going to do that as soon as possible. And by Monday night, Tuesday morning, if you don't see that quiz, it's coming very soon, okay? Okay, I will be in a Zoom meeting Tuesday morning if you want to show up. If nobody shows up, that's fine. That's okay too. Email me if you have any questions. The assignment on El Nino is a little bit technical. You're going to graph some data in Google Sheets. You have to do some hyperlinking for this like interactive map thing that I want you to make. And so I don't think anything is too complicated, but if you have any trouble at all, just email me. We can even do a separate Zoom meeting, and I can pull up my screen and show you exactly how to work through it if you have any technical difficulties. So just let me know. Email me. Okay. Thanks, guys. Have a good week. Bye.